All right, here we go. This is Unit 1, Lesson 2 for AP Precalc. And we're going to be going over, as you can see from here, factoring quadratics. Let me see if I can get my laser going. Yeah, okay, so this is the goal today. Guys, the plan will be for me to just go through a couple of each of these, but hopefully this is mostly review. Okay, so I'll try and do one or two from each of these pages, right? So here's the case where leading coefficient is 1. I think you have answers, maybe not, so I'm gonna have to load those up. Then we'll go on to leading coefficient is not being 1, right? Some examples here. And then we'll talk about solving quadratics by factoring. Some examples. Square rooting. And that is it. Okay, so let me go back to the very first part and work through these as quick as I can. Feel free to pause whenever you need. Okay, so first step, right? If we have a leading coefficient of 1, it's pretty easy because we're going to break that x squared or whatever the first thing squared is into its square roots. Okay, so in all these cases, we have something that's squared. This is going to break down as an x times x. This is going to be a b times b. This is going to be an x times x. This will be an r times r. This will be an a times a. Okay, so I'm going to pick, let's do a b, right? So if I'm going to factor this first one here, I know, sorry guys, I know that basically factoring means we're going to break an expression into smaller parts that are multiplied together, okay? That's what factoring is. So we have a trinomial here. We're going to break into two binomials multiplied together, and we know if that leading coefficient is 1, right here, b squared breaks down as b times b, okay? Then all we really need to do is look at the c component, right, the plus 9 here, and figure out what two numbers multiply to be 9 and add to be negative 10. Okay, so I'm going to write that over here because we're going to use that later. But we want to multiply a and c together. Okay, so we have 1 times positive 9. That's positive 9. And we want factors of that add to b. Okay? So that's probably a bad notation to make. Let's call this is dot for multiplication. The plus is for addition. Okay, so what two numbers that multiply to be negative 9 add to be negative 10? Well, that's easy. That's negative 1 and negative 9, right? Those two numbers multiply to be positive 9. They add to be negative 10, okay? And so those are the numbers that we're going to put in. Super easy, right? This is our answer, okay? If we take one more, or let's do a couple more, okay? This is a difference of two squares pattern right here. Hopefully you guys can see that. I don't know if you can. Probably not. Okay, so letter C here, this is the difference of two squares. If we start with that setup, in this case, a times c, that's going to be negative 64, right? And b is actually 0. Okay, so this technique that I'm showing you works for everything, right? What two numbers multiply to be negative 64 and add to be 0? Well, that's going to be plus 8 and minus 8. Okay, and I just realized here, guys, this is pretty bad here. I need to go back. This should be negative 10, and the resulting values that produce those two things are negative 1 and negative 9. Sorry, you can see I'm kind of trying to go fast here. It's a bad idea. Okay? So we computed our AC both times. And in this case, it was positive 9. In this case, it was negative 64. And then we looked at our B value. It was negative 10 here. Here it's actually 0. And we try and come up with two sets of numbers that satisfy those two conditions. If we have those and the leading coefficient is just 1, it's just a simple copy paste. Okay? Let's do one more. Maybe that doesn't factor. Or let's try. Let's look at letter D. Okay? So in letter D, AC is negative 10 and B is 5. Okay? AC, let me do it consistently the way I've been doing it. AC is negative 10. B is positive 5. Okay, and guys, this is how we know, we will get one that doesn't work, right? So I'm going to take and list all all the numbers that produce negative 10, all the whole numbers. So negative 1 and positive 10, and negative 10 and positive 1, okay? Neither of those combinations multiply to be 5, all right? And you're probably saying, Papa, you forgot a couple, and you're right. So I'm just going to put plus or minus 2 and 5. Okay, those also won't work. All right. So yeah, I just want to be clear. So here I'm changing the sign on one of the two numbers. Here I'm being a little bit lazy. 2 and 5 produce negative 10, or 2 times 5 produces 10. One of these can be plus or minus, right? So I'm just kind of being a little bit lazy, but either way, I can look at all these. Nothing's going to add to be positive 5. Okay, so we're done. This one, okay, is shoot. It's pretty. I'm hoping you guys are getting some entertainment here. So this is a does not factor. Okay. So hopefully that's enough, right? I want to get on to more difficult ones, but this same process of looking at A, C, and B work for everything. And look, if you guys can factor, great. I want you to pick the technique that works for you. There's a bunch of different ways to do it. I like this ACB method, but just get something that works for you. Okay, so if the leading coefficient is not 1, we're going to still do the same exact thing. Okay, so you have these steps here, but I'm going to write out sort of my own. So 1, we're going to compute AC, right? Whatever A times C is. And number 2, we're going to copy whatever the B term is. Okay? And then 3, and I'm just not going to write out the rest of the examples, but we want to find 2 numbers that mult to AC, and by mult I mean multiply, and sum to B. Okay? And then the step 4 will be split the middle, which means the BX term into 2. We're going to do that with whatever numbers we found in step 3. And then step 5 is we're going to factor by grouping. Factor by GRP, grouping. And that's going to be the first pair. So the first and second terms, and then the second pair. And it's going to just be a little bit easier, I think, if I show you. Okay, but that's basically the idea. Is we're going to split a trinomial into a quadratic, or an expression with 4 terms. We're going to factor the first 2 and the second 2. And then we're going to look for a common factor, and that's going to be the sign that we've got a factored form. Okay, so that's, yeah, exactly what they're doing here. Good. So let's look at this. So 2 times 15 is 30. That's our AC. Okay? And then 11 That's our b. Okay, so you can write it out on the side, right? You can write out, okay, well, I got 1 and 30, I got 2 and 15, I got 3 and 10, and I got 5 and 6. And I would encourage guys, just go start with the lowest number and go like in order, right? Once we get to 5 and 6, if we haven't missed anything, we know these are only possible values, okay? The ones that work are gonna be 5 and 6, positive, right? Because positive 5 and positive 6 is 11. Positive 5 times positive 6 is 30, okay? So that right there is getting our step 3, okay? And then if you notice, right, let me get, you guys will laugh, let me get a highlighter. So now we're gonna split, that's not what I wanted to do. We're gonna split the positive 11x into plus 6 plus 5x. Guys, it doesn't matter the order that we do it. Okay, I'll actually do it the other way and show that we get the same result. Okay, from there, what we're gonna do is look at the first 2 terms, look at the last 2 terms, and take out common factors. Okay, so that's what we have over here. This 2x squared plus 6x is the same as this. Okay, and then this 5x plus 15, well, we can take a 5 out. So that becomes 5 times x plus 3. Okay, so this becomes that. And then the way that we know that our form is correct is we have the same expression inside parentheses. Okay, then that final expression comes out. And what's left over at the end? Well, you have the 2x, which was the first component that we took the x plus 3 away from. And then we have the plus 5, which is here, okay? So that is, the cool thing about this is it always works, or it always, you can do it with any sort of form. If in this step you don't get a set of terms that produce your b, the expression is not factorable, okay? So now real quick, what I wanna do is just take this, I'm gonna flip the order and I'll show you that we still get the same result. Okay, so I'll put a star here. So if we had, for example, 2x squared plus 5x plus 6x plus 15, right? And we group, well, I'm gonna take an x out and that gives me 2x plus 5. Now, knowing that I wanna get this 2x plus 5, I can kind of see, oh, I wanna take a plus 3 out. You gotta be a little bit careful sometimes with your signs. Sometimes you might even take a 1 out, right? That happens. Sometimes we'll take a 1 out here. But yeah, then we get 2x plus 5, okay? And then I think it's clear that now we can factor this 2x plus 5 out of both, and we get the same exact expression in the end, right? So this is going to become, if I take that 2x plus 5 out, I get x plus 3, okay? This is the exact same thing as this, just the order's different. Okay? So guys, this is a really good method. If you don't have a method that works for you, this is a good one. Let's just pick this one, okay? I want you guys to have time to practice, but I do want to point out, you know, if we have numbers like this, what's a smart thing to do first? Again, we're factoring. And factoring means breaking down a single expression into smaller parts, multiplied together, okay? Don't forget, right, especially if you have big numbers, look for a GCF first, okay? So if we look at 12, 34, and 56, they all have a 2, okay? And that might not look like it's a huge help, but what it will do is just reduces what our AC is. Okay, so now AC is going to be 6 times 28. Oh man, you guys are probably doing this in your head. That's 12, 168. Okay, this is going to be awesome. And B is 17. B is 17. Okay, so I'm not going to start with 1 and 168. I'm going to start with 2 and 84, not close. 3 And let's see, what is that, guys? That's going to be 5, 56, 4, and 42. No. 6 and 28. Okay, sorry. 7. That might be it, actually. 7. That's going to be 2 and 24. Okay, hey, this looks nice, but I want a difference of 17 and I should have been more careful. I caught it, but it wasn't ideal, right? The AC is negative, right? Because we've got this negative C value here. Okay, so what we're gonna do is we're gonna split the 17 and we'll split it as minus 7x plus 24x, okay? We still have the 2, then we've got 6m squared minus 7, I think I said x, sorry guys, I meant m, minus 7m plus 24m minus 28. Okay, look for anything common in the first set, nothing except an m, so I'm gonna have a 2, and then I've got an m that comes out. This will be 6m minus 7, and then we want that same thing, so let's take a plus 4 out. 6m minus 7. Okay, so now our final form is gonna be 2. I'm gonna write this first. 6m minus 7, and then what goes in last is the remaining parts that we took the 6m minus 7 away from. Okay, so that's going to be m plus 4. So there we go. There is our factored form. Let's do one more. Let's do like maybe B. Sure. I was going to do C, but no, let's do B. Let's do C. I changed my mind. Changed my mind. Okay. So C, this was D here. So for C, I hate having negatives, so I'm going to take a negative out. And then we've got 10x squared plus 29x plus 10. So our AC, I'm gonna write up here to save some space. So our AC is positive 10 times 10, which is 100. And our B is positive 29. Okay, so actually that's right. I think we can maybe see this one right away, but 4 and 25 will do it. Okay, so negative stays out, and then we're gonna have 10x squared plus 4x plus 25x plus 10. And again, right, what we've done is we're split in the middle. We're replacing that plus 29x with plus 4x plus 25x, and that's because this is going to allow us to factor by grouping. So first two, let's do a highlighter because you guys love that. So what's common there? Well, we've got a 2x, right? So a 2x comes out, and then we've got a 5x plus 2. Now I sort of know I want a 5x plus 2, and I can cheat. What gives me that? Well, we take a plus 5 out. So final answer is going to be negative. Let's take the 5x plus 2 first, and then 2x plus 5, okay? And I'm just gonna keep it like that, right? We could distribute if you wanted to, you could move the negative inside there, yeah, but quick check, that's 10x squared, good. This is 25x plus 4x, it gives us 29, and this is the 10, so we're good. All right, so that AC method's really good. I think I'll stop here and do another video just to make sure that this is working. So I'll see you on the next video. We will talk about solving by factoring. Pretty easy once we know how to factor. And then square rooting real quick. Okay, so see you on the next video where we do this.